Okay, so in this practical you need to put in some errors. So you need to first put an error for the distance, and you can see that it's been done to the nearest millimetre. Okay, because that's what you should have for that reading, is something around about the nearest millimetre. The period, around about 0.01 seconds. 0.2 is also fine. Okay. Now you then have to do t squared d over t squared d, and to do that, remember it's you have to double the percent uncertainty of t, and then add that to the percent uncertainty of d. Then when you graph it, you're putting in these things here, these what we call error bars. So on the point, you put in the point like normal, like you normally do, and then you put in a point for the maximum value it could be. So in this case it was 0.84 plus or minus 0.025, something like that. Okay, so you've gone up there, up 0.025 and down 0.025. Okay, and you put those all in. Now the harder bit is now going to be doing the lines. And what you're going to put in, you're going to put in the maximum line and a minimum line. So looking at this graph, there is one line that goes through the middle just like normal, so just draw a straight line like normal. Okay, that goes through the middle of all the lines. Do that one, and you can see here it's the solid line. So it's a solid line in this case. Okay, so it's going up and down, and it's a solid line, and it just goes through each of the middle of all the points. The other type is the maximum or minimum line. So what you've got to do is get your ruler and turn it in such a way that this one's the shallowest one possible. So it goes to the bottom at the top and at the top at the bottom. You've got to try and get through as many of the lines as you can. And in fact, in the exam ones, you have to go through all the lines. Okay, so you need to go from, you put your ruler and you try and stay within the error bars and go as shallow as you possibly can. Then what you do is you then calculate the gradient of the line of best fit, just like normal, and then the least gradient line, and the error is going to be the difference between those two. Okay, so 3.94 is my normal value, and it's going to be plus or minus the difference between the two. And then you transfer the error into this final part, just like you normally would.